we've talked about a few different methods of charging, specifically charging by friction. So we used the electrostatic series, and we looked at when you rub two things together, electrons are transferred. Okay, so in this lesson, we're going to review two other methods of charging. The first is charging by contact. The second, which we'll talk about in a few moments, is charging by induction. Something to refresh our memory is that when we're talking about electricity, when we're talking about transferring electric charge, only the electrons move. Okay? So we're going to begin, and the way that we're going to do this is by showing diagrams. And we're going to begin with a diagram of some kind of insulated rod. Perhaps it's ebonite. And this ebonite rod is not neutral, but is charged negative. Okay? So you can see each of these, and there's an extra set of electrons on here. Now, we come down to some object, and we'll say it's some kind of a neutral conductor. And we are going to charge this neutral object by contact. Okay? So what ends up happening in this case is that we bring our insulating ebonite rod close to this neutral object. And of course we know that electrons repel. And so here we have our rod that's all charged up, and it's got, of course, an extra 1, 2, 3, 4 electrons. And because this overall is negative, right? So overall this has a negative charge. It comes close to this, and these electrons want to be as far away as possible from this overall negative object. So our electrons in this neutral object, this neutral conductor, all kind of scatter, and they go to the other side. And that's very common. And of course electrons will do that because these extra electrons in here are repelling these electrons in the conductor. And so these guys kind of scatter, and they try and get as far away as possible. So what ends up happening then is that we get contact. And that's why we call it charging by contact. 4, 5, 6, 1, 2, 3, 4. We're keeping the same number as possible. So these guys are still over here. And we've got 1, 2. All these ones all have their own electron. And we've got the extra 4. And so what happens as soon as we touch this is that this object in general, which is negative to begin with, it doesn't like having all those negatives in there. And so the charge will try and distribute itself evenly. And so some, not all, but some of the electrons, because of the contact, will then spread out so that we can have a nice distributed negative charge. So you got to think about it like this. At first, we had all the negatives, and they're all crammed into this ebonite rod, and they weren't happy because electrons repel each other. And so when we give them an opportunity to spread themselves out, yes, we're still going to have an overall negative charge, but they will be more spread out. And so what ends up happening then is after we separate the two, what we end up with is, well, these guys all had their negatives. These guys all had their negatives. But here, we had an extra 4 electrons. This guy, this guy, this guy, this guy. And they've spread themselves out so that, okay, now I got an extra 2 up here, and I've got an extra 2 down here, and we've balanced out this overall negative charge. So this overall now is negative, and this overall here is negative, but it's less negative than it was before, right? So here we had so much negative all built up in this ebonite rod. We contacted it. That negatives, those negative electrons kind of spread themselves out, and the consequence is that, yeah, okay, now both objects are charged negative because we still had an excess number of electrons, but the overall negative charge on the rod is less, and so everyone is kind of more happy, if you can think about it like that. Okay, so now charging by induction is a little bit different. Okay, charging by induction is a little bit different than charging by contact, because with induction, no contact occurs. Okay, so this is what's really important, is that there is no contact that happens when we charge by induction. So here's, let's say we have, we'll go with our example, an ebonite rod, and it's got a couple extra charges. And we've got our neutral object right here, and it's got our basically electrons and protons all balanced. And what happens is that we attach to the neutral object a ground wire. Okay, and so this is connected here, which gives electrons an escape route. Okay, a ground, as we've talked about, is a wire or is a pathway for electrons to either leave or arrive, and they can go to the Earth, because the Earth is either a massive supply or a massive sink for electrons. So here we have our negative rod, okay, and we bring it close to a grounded neutral object. So what happens then? Well, we know that our positives don't move. And so here we have a negative rod, and we had a neutral object that when we bring these things close together, like this, together, when these are in close proximity, when these are close together, all of a sudden now we've got too many electrons. So we've got a negative rod, and now all of a sudden we have a neutral. So overall, these things together, these two objects together, when we bring them close together, well, there's too many negatives. And the reason why we attach a ground is so that the electrons that are in the neutral object can leave. Because they're much happier. And what's left behind then is something that together ends up being neutral. Okay? So this picture right here, this third picture, is just to remind us that there is no contact involved and that the objects do not touch. Okay? And this is really important. The objects do not make contact with each other. So that's what this panel reminds us of. But here we come back to our object, and of course nothing's touched, so this is what's interesting. We've still got our rod, which was negatively charged, right? So, and nothing's touched. So this rod still has a negative charge. But when we bring it away, and of course now the ground is disconnected, what is left then is an object where, hey, wait a second, I had a neutral object, but I allowed these electrons to leave, because when we brought the negative rod close by, it scared these extra electrons away, so they left through the ground. Well, then if I disconnect the ground, there's no way for those electrons to come back. And so what ends up happening is that I get an overall positive charge, okay, that's left on the object. And so this is an important distinction between contact. With contact, I have a negative object, I bring it close, I touch it, and they both end up getting a negative charge. So they both end up getting the same charge in the end. They're a little bit less negative, but they still get the same charge. With induction, I bring a rod in close, electrons leave, and in the end, they're charged opposite. And so that's an important distinction. So we're going to talk much more about these two methods of charging, but this is kind of the introduction for what you need to know so that we can really get into this in more detail tomorrow.